Hello folks, welcome you all. I am Prakhar Mishra and today we are going to start the very interesting topic of arithmetic progressions. So before diving deep into it, let's talk about some basics. So here you can see that I have written down some sequences of numbers. So let's go one by one. In the first sequence, you can see that it starts from 1. Okay. So it starts from 1 and if we add 2 to it, we'll get the next term, that is 3. Again if we add 2 to 3, we'll get the next term as 5. Again if we add 2 to it, we'll get the next term as 7 and hence the sequence is separated. Let's dive into the next sequence. We're starting with 6. So if we add minus 3 to 6, if we add minus 3 to 6, we'll get 3. Again if we add minus 3 to plus 3, we'll get 0. Again if we add minus 3 to 0, we'll get minus 3. And again if we add minus 3 to minus 3, we'll get minus 6 and hence the sequence is separated. Let's focus on the last one. It starts with minus 4. So if we add minus 5, if we add plus 5 to it, if we add plus 5 to minus 4, we'll get 1. Again if we add plus 5 to it, we'll get 6 and so on and so forth. Our sequence is generated. So in all these three sequences, you have observed one thing, that there is a fixed term involved in each of the cases. This fixed term is called the common difference of the sequence and hence this sums up the definition of arithmetic progression. So let's go term by term as to how an arithmetic progression is defined. So an arithmetic progression or an AP is a series of numbers, like as you can see here also we are having a series of numbers in which each term is obtained. Each term is obtained by adding a fixed number, to the previous term except the first term. So these three encircled terms in the beginning are the first terms of the AP and they are denoted by A or A1. So these are the first terms and the fixed term which is added to these first terms consecutively to get the subsequent term is called common difference. Common difference. So the common difference in the first sequence D1 is plus 2. In the next sequence the common difference is minus 3 and in third sequence the common difference is plus 5. Why I am deliberately telling you the signs of this common difference is because as you can see here the definition, I have underlined it specifically that each term is obtained by adding a fixed number to the previous term. So one and only thing you have to keep in mind that in forming any arithmetic progression you have to only add a number irrespective of its sign convention. Like if it is minus 3, then you have to add minus 3. If it is plus 5, then you have to add plus 5 to it, to the term to get the subsequent term. So don't get confused with the signs. Okay. So let's proceed further and write down a general sequence of how an arithmetic progression is formed in mathematics. So if suppose we have the first term as A being the first term, then by definition the next term would be A plus adding common difference to the previous term, that is A plus D. It would make the second term. Likewise, the third term would be A plus D because A plus D is the previous term, adding common difference to it would make the third term. And likewise, a plus d plus d. This is the previous term. Now I have added common difference to it. It would make the fourth term. So likewise, we derive the formula of nth term of the sequence. So here you can see that the we also rewrite these terms as now we can proceed on to the nth term of the sequence. So the first term is a, second is a plus d, third term is a plus 2d, fourth is a plus 3d. So here you can observe that in the first term d is not added, or you can say d is added 0 times. In the second term you can see that d is added only once. In the third term d is added twice. In the fourth term d is added thrice or 3 times. So what we can say that in any of the terms, suppose in any nth term means any arbitrary term of the sequence. So in nth term d would add up n minus 1 times, because in fourth term it's added 3 times, in third term it's added 2 times, in second term it's added only 1 time. So in nth term it would add n minus 1 times. Hence this constitutes the nth term of the sequence. So nth term is also denoted by an, which is a plus n minus 1 d, or it can be written as a1 plus n minus 1 d, a1 being the first term of the sequence. So this is how we derive the nth term of the sequence. So now let's move forward and see the consecutive definitions in arithmetic progression.